Now we're going to talk about quotients of radicals. Now, quotient can mean many things. Quotients usually mean division, and it's the answer to the division problem. But a quotient can also be just the fraction that makes up the division problem. So when we think of quotients of radicals, we're going to be really dealing with fractions and how to look at that numerator and denominator. The most thing that when we're dividing with radicals is to remember you can never have a radical in the denominator. If you do, then it is not in the correct form and you need to change it and get the radical out of the denominator. If you can get rid of the radical by dividing, that's the easiest answer. And so I'm going to show you what that looks like. Let's say the first thing we need to know, though, is the property. This is a property that's going to help us get rid of the radical by dividing. And this says that the square root, or the radical, of a fraction, x over y, which is x divided by y, is the same thing as saying the radical of x over the radical of y. This is getting you the radical in your denominator, which you don't want, but it's important that since this is an equal sign, that it works both ways. If you have the radical of x over the radical of y, you can rewrite it as the radical of x over y. So let's see this in action. Let's say that we have the square root of 12 over the square root of 3. Well, using our property, that becomes the square root of 12 over 3. Well, 12 over 3 is just 4, and then the square root of 4 is 2. So there we go, simplified. What about the square root of 6 over the square root of 25? Well, using our property, we're not even going to use our property. You can recognize that the square root of 25 is just 5. And you didn't even have to use the property. You didn't have to divide. All you did was state that the square root of 25 is 5, and now you no longer have a radical in the denominator. Stop. You're done. You don't have to do anything else. Just leave it just like that. You don't have a radical in your denominator. You don't have to do anything else. All right, let's see if you can try to figure out what this one is. This is the square root of 24 over the square root of 8. So go ahead and pause the video, see what you think the answer is. All right, the answer is 3 because our properties are, the answer is the square root of 3, which is number 2. So the reason that we got that is the square root of 24 over the square root of 8 becomes the square root of 24 over 8, and 24 over 8 is 3, and so that gives us that answer, the square root of 3. Okay, so we talked about you can never have the radical in the denominator, and the easiest way is that you can use that property and divide evenly. But what if you just can't divide, like it's not going to divide evenly? Well, there are other ways. We can get rid or eliminate the radical by rationalizing the denominator is what it's called. So getting rid of the radical in the denominator is called rationalizing the denominator. So you need to know that term, that phrase, rationalizing the denominator. And what does that mean? Let's look at 3 over the square root of 5. So this is obviously can't be divided. 3 doesn't even have a square root over it. So there's just no way to simplify this, but we still need to get rid of that radical. Well, we know that in fractions, that anything that is the same in the numerator and the same in the denominator is equal to 1. And we know that if we multiply anything by 1, it's still itself. So let's remember that the square root of 5 times the square root of 5 is 5. So we eliminate that denominator. So we can easily eliminate the radical in the denominator by just multiplying it by itself. So if we do that, though, if we multiply the denominator by itself, we just can't multiply something by the denominator. We had to do the same thing to the numerator. So this times square root of 5 over square root of 5, remember that's just saying times 1. So we're not really changing the number. The number is still the same value. It still holds the same value. We are just getting rid of the radical. So the square root of 5 times the square root of 5 will become 5 for your denominator. And then in your numerator, you'll get 3 times the square root of 5, which is 3 square roots of 5. All right, what about 6 square roots of 14 over the square root of 10? So in this case, if we use the division, we'll get 6 square root of 14 over 10, which reduces to 7 over 5. So it didn't really divide evenly, but we still reduced it, which is good. So 6 square root of 7 over 5. So that goes back to 6 square roots of 7 over the square root of 5. So now we're going to multiply by the square root of 5 on the numerator and the denominator. So in the numerator, we've got 6 times the square root of 7 times the square root of 5. And we learned in the last chapter that when you're multiplying square roots, we just multiply what's on the inside. So we get 6 square root of 35. And in our denominator, we have rationalized the denominator, which means that we get 5 for our denominator. All right, what about 2 square roots of 3 over the square root of 10? So 3 and 10 will not divide evenly, and it won't simplify. So we're going to go ahead and go straight to multiplying by the square root of 10 in the numerator and the denominator. So 2 times the square root of 3 times the square root of 10 gives us 2 times the square root of 30. And then we've rationalized our denominator, giving us 10 for our denominator. And this is not quite simplified because 2 goes into 10 5 times. So there we go. There would be our answer, the square root of 30 over 5. Okay, so let's see if you can attempt this one. I'll give you a moment, pause the video. Okay, so you should have gotten number 3, which was 3 square roots of 7 over 7. So 3 and 21 reduces to 1 and 7, right? So you get 3 square root of 1 over the square root of 7. Well, the square root of 1 is just 1, so you get 3 over the square root of 7. And when you rationalize your denominator, you're going to multiply the numerator and the denominator by the square root of 7. So on top, you get 3 square roots of 7, and in your denominator, you'll get 7, which is answer number 3. All right, so go ahead and attempt this one. Okay, you should have gotten number 1, 10 square roots of 3 over 3. Now this is one where we could have divided because 6 and 2 become 3. So that gets rid of your radical in the bottom, giving you just 10 square roots of 3 over 3. Okay, so this right here, notice how the only difference between these two is the minus sign, right? That's the only difference. You have the same terms, but instead of plus, you have minus. When you have this, when you have a number plus another number and a number minus a number, and the A and B are the same thing, the only difference is the plus and the minus, we call that conjugates. So it's the same terms, but opposite signs. And conjugates are super useful. So say we have, in our denominator, we have a radical, but it's a binomial. So it's not just the radical, but it's the radical plus something else. We're going to multiply the conjugate to get rid of the radical when there's more than one term in the denominator. So again, if it was like a binomial, we'll use the conjugate. So for example, 3 over 2 plus the square root of 3. We can't just multiply by the square root of 3. That's not going to work for this one. We have to multiply by the conjugate, which would be 2 minus the square root of 3. And we would do that in the numerator and the denominator. And if you use your box method, you'll find out that the square roots of 3 will cancel out. And it's very nice. And so that's why we multiply by the conjugate. So what that looks like is in your numerator, 3 times 2 minus the square root of 3, we have to distribute. So that becomes 6 because 3 times 2 is 6. And then 3 times minus the square root of 3 becomes minus 3 square roots of 3. So that's how we get our numerator. For our denominator, we use our box method, right? So 2 times 2 becomes 4. Okay, and then 2 times negative square roots of 3 is negative 2 square roots of 3. And then 2 times the square root of 3 is 2 square roots of 3. And then the square root of 3 times negative square root of 3 becomes negative 3, because remember the radicals cancel each other out. So now we've got 4 minus 2 square roots of 3 plus 2 square roots of 3 minus 3. And you're like, wait, Miss Moss, the radical is still our denominator. We just made a huge mess. But if we combine like terms, 4 minus 3 becomes 1, and then negative 2 square roots of 3 plus 2 square roots of 3, that just cancels out. So now we've just got 1 in our denominator. So we've got 6 minus 3 square roots of 3 over 1, which is just 6 minus 3 square roots of 3. So conjugates. What is the conjugate? Let's see if you can figure this out. 5 plus the square root of 7. What would be the conjugate there? Okay, you should have said 5 minus the square root of 7. What about negative 3 plus the square root of 2? What's the conjugate for that one? Okay, you should have said negative 3 minus the square root of 2. So nothing changes about the signs. You're just switching the plus or the minus between the two terms. So what about 4 minus the square root of 6? What's the conjugate there? Okay, you should have said 4 plus the square root of 6, because the subtraction is going to turn into addition. So the conjugate of 7 over 3 plus the square root of 6, so 3 plus the square root of 6, the conjugate would be what? And you should have gotten the answer 3 minus the square root of 6. That would be the conjugate. That's what you would want to multiply by to get rid of the radical. Okay, so 7 over 3 plus the square root of 6, you're going to multiply by the conjugate to get rid of your radical. And when you do that, in the numerator, you're going to distribute that 7. So 7 times 3 is 21. 7 times minus square root of 6 is negative minus 7 square root of 6. And then you can use your box method to multiply the conjugates. So 3 times 3 is 9. And then 3 times negative square root of 6 is minus 3 square root of 6. And then 3 times positive square root of 6 is positive 3 plus 3 square root of 6. And then the square root of 6 times the negative square root of 6 becomes just minus 6. So then we get the answer 21 minus 7 square roots of 6. And the 9 minus 6 is 3. And then these two terms here, the minus 3 square root of 6 plus the 3 square roots of 6, those cancel out, just leaving you 9 minus 6, which is 3. And so we have 21 minus 7 square roots of 6 over 3. All right, so let's go ahead and test your skills. What would be the answer here? The answer would be number 2. Number 2. What about 2 index 4 of 6? You would multiply by 4, the square root of 6 cubed. And you're like, well, why are we doing that? It's because we're no longer using the square root. So when you do that and you cancel out the radical symbol, 2 times 4 roots of 6 cubed, 6 cubed is 216. So now you have 2 to the 4th root of 216 over 6. and then 2 over 6 reduced to 3. So now your final answer is 4 roots of 216 over 3. Okay, so now it's your turn. You're going to do 2 through 6 evens on 7.5.